Okay. Okay, before going into that yesterday's problem, I want to show you this. So different ways of expressing P tends to Q. So these are the two things that is needed for us. 1 minute. P only if Q. If that type statements you find, then you have to write it as P tends to Q. Okay, so 1 minute. Can you see here? So all the symbolization we used. Second statements, he eats crackers only if he drinks milk. What? What is the problem? My voice is not audible.
Yes, ma'am, you're audible.
1 minute, I'm getting a call, just 1 minute. Okay, I'm sorry. See, so first statement, no problem. If he takes coffee, he does not drink milk. That is P. He does not drink milk. So P tends to not of Q. First statement, okay, no problem. Second statement, he eats crackers only if he drinks milk. P only if Q. That format, no, it should be P tends to Q. So what is he eats crackers? It is R. If he drinks milk, Q. So it should be R tends to Q. Second statement. Yesterday, I think we have written it as Q tends to R. It should be R tends to Q, right? So that's why I referred that again. Then third statement, you have to remember this. Q unless not P. Q unless not P. Whenever you find such type of sentence, you have to assume that as P tends to Q. Q unless not P. That means, see here. This is Q unless this is not P. That format it is there. Hello? Can you all hear me? So what you have to write, it should be written as P tends to Q. So what is P? If you take not P as
Yes,
he eats, if you take P, he eats crackers as not P, now what should be P then? He does not eat cracker, right? So you should write P tends to Q. He does not eat cracker means what? What is he does not eat cracker? Not R. So not R tends to. He does not take soup. He does not take soup is what? Not S. So not R tends to not S, comma P. P, I think you know already it is given. Uh, can we say that he took soup at noon today? Okay, that is P. So combining all these four statements. Oh, I think I'm sorry. P is nothing but he had coffee. So all these four statements are given premises. We have to check whether conclusion is he took soup at noon today. That is Whether yes is the conclusion, you have to check. If yes is not the conclusion, then what is the conclusion? So if you want, I'll repeat once again all the premises. First statement, no problem. If he takes coffee, he does not drink milk. That is P. He does not drink milk, not Q. So P tends to not Q. Second statement, P only if Q, that type of statement is there, no? Then you should write that as P tends to Q. So he eats crackers only if he drinks milk. No? Then you have to assume if he eats crackers, then he drinks milk. That is R, then Q. That is R tends to Q. So second statement is okay. Third statement, it is like unless something, right? So Q unless not P, you have to take it as P tends to Q. So that means this is your Q and this is your not P. So what should be your P then? Q unless not P is this one. Now you have to write that as P tends to Q. So what is P? Negation of this. He does not eat cracker. That means not R. Then what is Q here? Q you have to write. Q is he does not take soup. So but here what is the symbolization? He takes soup is yes. He does not take soup is not yes. So not R tends to not as comma P. So we have to use all these four statements and we have to derive at the conclusion. P tends to not Q. I think somebody gave me the result yesterday. He has written and sent it. Who was that?
It was me, Parth.
Parth, yes, beta, you are right. P tends to not Q. Only thing is I didn't reply because I didn't find time. R tends to Q. Not R tends to not S, comma P. Okay. So can you say how to proceed? Others? Please think about it. How to start with? First sentence, what you can take? Shall I take these two? P tends to not Q. Rule P, then P. Rule P. If you combine these two things, then it is not Q. What result you have used here? What rule you have used here? So from one
Modest ponens.
modest ponens. Using modest ponens. So one more word you can add, rule T, yeah, something you have derived newly. Then which one you can introduce?
And now R tends to Q and not R tends to not S after that.
First you use this. You can use these two terms. Then you can introduce them. Clear? Hey, there is another way of doing it also, yeah. I'll tell that. Let us complete this. One more way you can do. Tell me. If you use these two, what result you will get?
Not I. Not R.
Hey, 1 minute. I think somebody have come from corporate. Hello. Sorry. Okay. It is not moving. Okay. So not Q, comma R tends to Q. If you combine these two things, what will you get? If you combine these two things, what will you get? Hello.
Not R.
Not R. What you have used actually? What is that rule called?
Modest tolerance.
Modest tolerance. Modest tolerance.
Yes, ma'am.
Then now you can introduce not or tends to not S. So combining 5 and 6, what will you get?
Not S.
Not S. Using mod exponents in 5 and 6. What is the actual conclusion? Not S. But we have been asked whether yes is true. No, yes is not true, not S is true, right? So the actual conclusion is not S. That is, he does not take coffee. Yeah, sorry, he does not take soup. Clear? Okay, ma. Shall I proceed?
Excuse me, ma'am.
Yes, ma.
I mean, the previous case we took the reverse, right? When only if comes. Now, which one to follow?
Which previous where we have taken?
Like in one problem, when we got when we are not able to derive, we took only if as a reverse case.
Can you please point out that problem in module 1?
Yes, ma'am. Maybe I'll look at it.
You look and say we'll correct that. Maybe the question might be wrong. We'll change it.
Okay.
Please point out that. Yeah, we'll change that.
Okay, ma'am.
Maybe in the next class you tell we'll change that problem. Plus, please remind me, we'll change that question. This is the actual thing. Okay, shall I proceed now? We'll move on to the next. I think we need to, which question you have completed? Third and fourth, I told. You have completed?
We completed fourth. Third, you said we do then.
Sure. Okay. Third question. Translate each of these nested quantifications into an English statement that expresses a mathematical fact. So the domain in each case consists of all real numbers. So they specifically said all values of x and y are real values, right? Okay, so can you please read out that first statement? Yes, ma, tell me. That question you got?
was sunny this afternoon and it is colder than yesterday. We will go for swimming. That cannot
That
trip, ma'am.
question. So 1 minute you wait. Okay, so I'll look into that problem. Monday's class I'll correct it. Monday we have a class, right?
Yes, ma'am.
Monday I'll correct it.
Okay, ma'am.
No, I'll look into that question. Where is the problem? Actually, whether the problem is wrong, I'll find it out and tell you. Correct it. Thank you. Now, can you please translate this first sentence? There exists x for all y. X into y is equal to y. Just you use English and just say, there is a real number for every real number. There is a real number x for every real number y, such that,
Their product is
yes. Yes, can you please say it properly?
their product is y.
My product is y.
The real number y. Yeah.
So what is that x actually?
1 month.
Multiplicative identity. For
Multiplicative identity. Okay, so there exists a number, real number x, such that, okay. Can you please say it now? Start like that. There exists a real number x. Such that when it is multiplied by any real number, it gives back the
real number itself.
Real number itself. There is a fixed real number x such that when it is multiplied by any real number, You need not say y there. Any real number. Okay, it gives back the real number. It's up to you, but the thing is, the way you are saying it should be correct. Okay, second sentence. No, ma, second sentence.
Can you repeat the first sentence once if possible?
First question.
Yes, my first problem.
First question. Okay. So there exists a real number x. For every real number, there exists a real number such that when any real number, okay, I'll write better. There exists a real number x
Such that it is multiplied by any real number y.
Such that when it is multiplied by
any real number y returns the real number itself.
Any real number y returns the real number y. If you want to be more specific, say y itself, so that there won't be any mistake while you're saying. Okay, this is correct. Second one. Okay, you write this, think about second. Yes, ma, tell me.
Ma'am, like there exists a real number z that can be expressed as a sum of any two real numbers.
Is that the correct way of saying?
Ma'am, because for
then I should have started with there exists z first. It's both mean one and the same, but the stress, where you give a stress, right, that differs, right? For all real
numbers, there exists a z which can be expressed as their sum.
Okay, can you please repeat? Correct.
For all real numbers, there exists.
For every, you write like this. For every pair of real numbers, x and y, there exists a real number z, such that
z is the sum.
The sum of the pair is equal to z. Okay.
Yes.
Correct. So every pair of real numbers x and y, comma, there exists a real number z such that sum of x and y is z.
Ma'am, should we need to specify for in generally, or like we have to specify x and y, ma'am? We have to write it in general, right?
General you can write. That's what every pair I said, right? That itself generalizes. But how to write? So without x and y, can you say? Then that is okay. For every pair of real numbers, there exists another real number. Z, at least one time you have to specify. There exists another real number, z, such that z is the sum of those two real numbers. That way you can write. You need not specify x and y.
Ma'am, or can we write like for the sum of any two real numbers, there exists a number z which is also a real number?
Okay. Correct. That is the sum of every pair of real numbers is always a real number. Correct? Okay. Okay, what about the third one? So this is logic here. It has many answers. Only thing is, it should not deviate from the actual meaning. That's the only thing. Don't deviate the actual meaning. Don't deviate from the actual meaning. Otherwise, you can write it in many ways. Okay, what about the second question, B part? So they themselves, they have declared T of x comma y denote x can teach y, right? So where the domain consists of all the people in the world. So you need not worry about universe of discourse now. Assume that universe of discourse is there. They have specified from, we are going to take only the values only from the people in the world. Okay. So use quantifiers to express each of these following statements. Everybody can teach everybody, please.
Ma'am, is it for all x,
Hmm.
for all y, t x comma y?
Yes, is she right? Others? Correct, huh?
Yes, ma'am.
Yes, ma'am.
Yes, yes, she's right. For all x, for all y, t of x comma y. Exactly. Second one. Everybody can teach somebody. It's very simple.
For all x, there exists y, t x comma y.
Yes. That's it. Maybe after this, we'll look into that Sunny, that question, if time is there. Okay. Fourth question, shall we move? Fourth, you have completed. I asked you to complete this. Have you completed? Hello.
Yes, ma'am.
Okay. So what is the question? Let C of x be the statement x has a cat. D of x be the statement x has a dog, right? And f of x be the statement x has a ferret. What do you mean by ferret? Just Google and tell me what is ferret.
It's is a domesticated polecat which is used to hunt rabbits.
Oh, it is a domesticated.
Polecat.
Oh, okay. Wild animal, right? Okay. Check. 1 minute. 1 minute. I'm coming back. Just to do this. Sorry, there is a small inquiry. Okay, sorry. Okay, what about the first sentence? 4A. Hello. Oh, are you all there?
Yes, ma'am.
All students in your class have a cat, a dog, or a ferret.
Ma'am,
Ma'am,
for
can we make a new quantifier like say in your class?
Yes, you have to use a quantifier. Yes, of course.
No.
For all x. Okay. X belongs to what? All students in your class. So, but here domain consists of all students in your class. So for all x, x has a
C
cat.
of X.
Cat, no, C of x.
Cat.
Or
Or will come.
Or
D of
D
x
of X or F of X.
or f of x. Okay. Okay. Second one.
And there exists a student.
There exists a student.
C of X
Yes.
and F of X and not of D of X.
And not of D of x. Very good. Okay, this is very simple. Okay. Express the statement. There is a number x such that when it is added to any number, the result is that number. And if it is multiplied by any number, the result is x. As a logical expression. Can you try?
Ma'am, can you show the previous slide once, ma'am? Okay, ma'am, thank you.
Sorry. This one you think about it. There is a number x such that when it is added to any number, the result is that number. That means x, when it is added to any number, x is there.
When it is added, means it's y, right?
Huh?
When it
That
is
number, y,
it is
y, sorry.
multiplied,
Sorry.
it's x.
Multiplied, the result is x.
it's 0. It's additive identity.
0.
Yes, ma'am.
X is 0. Correct. Okay. So I'm not asking you the answer. How to symbolize this? You identified the answer. The solution to this is x equal to 0. But how do you write this symbolically?
And there exists X.
There exists
All
x.
y.
For all y, yeah.
Yes, ma'am, for all Y.
Because when it is added to any number, so for all y.
X plus Y is equal to Y.
And
xy equal to x.
Yes.
so if you don't like this way of writing, here even you can give a symbolization for this. If you want, you can symbolize this statement. What symbolization you'll give? It's not that much easy, right? X plus y equal to y. Okay, you can write this way itself. I don't think what symbolization you'll give for this. You can write like this. This is enough. They have given this way. See, let p of x comma y denote this one. Denote this one. But instance we have written directly this thing. That's all. Both mean what the same. If you want, you can make this as p of x comma y. P of x comma y denotes x plus y equal to y. Q of x comma y denote x star y equal to x. And you can write this way. Okay. Shall we proceed?
Yes, ma'am.
For what universe of discourse does this statement hold?
Real numbers.
Real numbers. All real numbers, this will be true, right? So this is true for all real numbers. Okay, correct. Yeah, I should have removed the answer, but anyway. Let P of x comma y denote x is a factor of y. X is a factor of y. What do you mean by factor? Can you give me one example? What do you mean by factor?
Y is divisible by x.
Y is divisible by
X.
Okay. Where x is equal to 1, 2, 3, etc. Y is equal to 2, 3, 4, etc. Okay. They have given specific domains for x and y. Let Q of y denote for all x, P of x comma y implies x is equal to y or x is equal to 1. So when is Q of y true? When is this statement true? They are asking. Don't see the answer and say directly. Justify. See, P of x comma y denote x is a factor of y. Okay. That is y divides x. Okay. So they are saying for all x, P of x comma y, whenever this is true, whenever x is a factor of y, then either x and y are same or x is equal to 1. So for what values this is true? What value of this it is true? Y, it is true. Why they are saying for only for y a prime number it is true. When y is a prime number, what can we say? Whenever
The
y is
factors of a prime number is a number itself and 1.
okay.
So that will satisfy x is equal to y and x is equal
Y or x equal to 1. Correct. So whenever y is a prime number, when x divides y, then the value of x can be either y itself or x equal to 1. That is the thing it is given in then part. So that itself shows that y value is a prime number. Correct. Good. Well, a very simple sentence here. You know, all rabbits are faster than all tortoises. Is this sentence clear? Can you understand this? They have taken the universe of discourse. What universe of discourse they have taken here? Let R denotes set of all rabbits, T denotes set of all tortoises. So for all x in R, x values taking in R, and for all y in T, C of x comma y. You can write C of x comma y denote x is faster than y. So for all x, for all y, C of x comma y means what? All rabbits are faster than all tortoises. Instead of specifying separately mentioning, they have written R for all x belongs to R and for all y belongs to T. Separately, the what universe of discourse they have specifically mentioned here. Okay. We'll have easy sentence here. Okay, before going into this, I'll find out that question. Module 1. This question? Hello?
Yes, ma'am.
Okay, ma, we'll do
Yes,
this.
this is the question.
Okay. What happened? Where are those sentences? 1 minute. I pressed something wrong. Okay, what are the atomic statements that we need, right? First, it is sunny this afternoon. Okay. P. It is sunny this afternoon. Okay, then it is colder than yesterday. We go for swimming, huh? We go for swimming. We'll take a canoe trip. By sunset. Okay, what is the first sentence? It is not sunny this afternoon and it is not colder than yesterday. So what is given? No, ma'am. It is not sunny this afternoon and it is colder than yesterday. Ah.
Not P and Q.
This first sentence. It is not sunny this afternoon. Not B. And it is colder than yesterday. Q. Okay. Second sentence. We will go swimming only if it is sunny. Okay, I'll write. We will go swimming only if it is sunny. So you have tried, this is P, this is Q, yeah, it is sunny. P tends to Q format, you have tried. So this should come first. We will go swimming. So R tends to, if it is sunny, that is P. Correct, our second sentence, fine. Hello? Oh, yeah, are you all listening?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Initially also we did this only. R tends to P.
Initially also we did the same thing. Okay.
Yes, ma'am. Like initially,
But
like
it's a problem. I'll come back again. Don't worry. We'll try. If we do not go swimming, then we'll take a canoe trip.
not R tends to S.
Okay. If we take a canoe trip,
S tends
then
to
we'll be home. S tends to
T.
T.
And then
Conclusion is we'll be
T.
home by sunset. One minute. Let me check whether this will give the correct conclusion. These two will give not these two, so not or will give yes, yes. Yes, it will give. Initially, we had the same thing, but we didn't get the answer.
No, ma'am. See, the problem here is that in the question that we did today, we didn't get the answer according to this pattern for R tends to P.
Ah.
See, here we have
Today's question we did correct only. Only if means we have to take R tends to P only, correct only. Same thing we followed. Should I go back to that question again?
Yes, ma'am.
1 minute, I'll go back to that question. One minute, see this. He eats crackers only if he drinks milk. So it is, if he eats crackers, then he drinks milk. He eats crackers is water, R. So R tends to, if he drinks milk, Q. The same thing I have taken.
No, ma'am. See here, he eats crackers is R. That's the first part of the sentence, and only if then he drinks milk is the second part of the sentence. That is Q.
Okay.
But in
Here
the
also the
question
second.
in the question that we have in the first module, it is the reverse of that.
Okay, see here. We will go swimming only if it is sunny. Same format only it is there.
Yes, ma'am. So here we will go swimming. That is represented by R. And if it is sunny, then it is represented by P. Okay, okay, yeah.
Correct, huh?
Yes, ma'am. Yes, ma'am.
Got it. So now after this, I think it is easy. Okay, one. Which one we can take first? Shall we combine these two? Not R tends to yes, P. Okay, yes tends to T, rule P. So combining these two, not R tends to T. What you have used?
Hypothetical syllogism.
Okay, hypothetical syllogism of 1 and 2. Okay, ma, then. Next.
Not P and Q.
Not P and Q. Next. So from that, not P is true. Okay, va? Now.
Yeah, then we can take R tends to P from that.
So then R tends to P or not R. Sorry.
Modest tolerance.
5 and 6, modest tolerance.
And then we have T.
Then we have not R tends to T. Rule P. So combine these two things, you'll get T. Why should I take this here? That's what you said, rule T directly. Okay, ma, I'll remove this. Not needed.
Yeah, 3 and 7 modest ponens.
T from 3 and 7. Modest ponens. Okay, this is the correct answer. If you want, you can write it. Please. You're taken down, you say.
Ma'am, can you go to today's question?
Inma, which one?
And that only if part we did today.
Ah. So whenever you have a statement P only if Q, then you have to mean that as P tends to Q.
But then in today's question, it was the sentence was like he eats crackers only if he drinks milk, right?
Ah, unless that was different.
No,
Unless
it is
different.
only if.
No, 1 minute.
He eats cracker only if he drinks milk.
1 minute.
The second sentence.
Ah, yes, I have taken if he eats crackers, then he drinks milk. That format only I have taken.
Okay, okay.
R tends to Q only I have taken. Correct?
Yes, sir.
Hey, please do look into that. Yeah, that particular slide I have shown you today, right? Please look into that. Okay. Have you taken down?
Yes, ma'am.
Okay, 2 absentees are there.